Hey everybody, it's Nicholas with JMZ Online, or Jim's Automotive Machine Shop Inc. Here we've got a 6076 John Deere up on the boring machine that we're going to be surfacing the deck, doing the upper counterbores after we surface the deck, as well as working on installing some lower counterbore repair rings. So these are the rings that we're going to have to be installing down there, and I'm just going to walk you guys through kind of the process of what we're going to be doing on this. It's actually going to be kind of a first for me. Dad has done it before, but I personally have not, so it's going to be kind of a learning process for me, and I thought that might be fun to show you guys, and might be an interesting, little bit different repair than you might normally see. Don't want to forget to leave these dowel rings in, or that would be a bad day. This dowel ring wanted to fight me, but I got it. Alright, so we've got it fixtured up, got the dowel rings out. First thing we're going to do is basically surface the top, and then we'll come back and we'll clean up the counterbores, and we'll do our measurements, and if we have to, we'll come back and surface it again to get them at the correct height. Hopefully we don't have to, but we'll see. So I'm starting here with decking the block, and we want to take just as little as we can just to clean up. So I'm starting with just a 1 thou cut here, and we'll see how that does. So we've got the deck cleaned up. Ended up taking 5 thousandths off of it. Now I need to switch over to one of our boring heads so that we can do the counterbore. And because of how far over I set the block, I actually can't use the nice tool changing carousel that we have, or caddy, or whatever you want to call it. So I'm gonna have to do this a little differently, and I guess lesson learned for the next one. If you've watched my TikTok or Instagram, you may have seen the videos showing the spindle caddy that makes it easy to change between the surfacing head and the boring head. I couldn't use that here due to the position of the block, and I knew the head was pretty heavy, so after a bit of contemplating, I decided to use the hoist. Now, a lot of people always ask how we center up on these blocks, to be centered on the cylinder again, and I'm going to show you that here in a minute, but I'm going to be centering on this part of the bore right here. So I'm actually just really lightly touching that with a wire wheel, just so that we can get that cleaned up so that we can get a good center, because obviously with some of this that's a little rusted up and corroded, that'll throw off our centering. Now, as for getting the block level on the fixture, on an inline block like this, it's pretty simple. You just set it down, put a level on the top, and usually it's pretty level. If not, it's kind of a guessing game of, okay, why is it not level? Was it wrong from the factory? Has somebody else done it along the way, and is it wrong? Or do I genuinely have, something under one edge of it that's making the block unlevel? In this case, I put it on here and everything was good to go. As far as for centering up on the bores, as far as indicating, all we have to do is put this finger in here in the machine, and you can see as, the high and low spots are going to move that finger, and that moves this gauge up here back and forth. So when I turn this on, you can see it spins around the bore there, and that's about as centered as it's ever going to be. So I can tell we're pretty centered on the block. I'll just show you just for fun. If I move it, a few thousandths off, that's 8 thousandths off to one side. You can see that needle is really moving back and forth. But if I go back to my 0, if I can hit it again, move my Y a little bit, we're pretty good. Alright, so I went in and I cleaned up my first counterbore, and I'm going to kind of go backwards and show you some of the process. I just wanted to do the first one so that I had everything good and was kind of focused on doing it right before I started trying to make a video of it. So now that I've got this one cut to what I've decided is the correct depth, I'm going to put a sleeve in, and we'll measure the sleeve protrusion and make sure that it's within our spec. So the spec for this sleeve protrusion is between 1/1000th of an inch and 4/1000th of an inch above the deck. So I'll just put my depth gauge here, and we can see there we are just under 4/1000th, which is where I'd like to be. And I'll just kind of check various spots. Pretty much same range. As long as we're within that 1 to 4 range, we're good. And we are. So now, by doing that, I set my Z axis on my DRO to 0 once I got to that depth. So at this point, I should be able to cut all of them to that same depth, and they'll all be in the correct range. Obviously, I'll go through and double check that, but we have pretty good faith in our machine that we'll be able to do that. And these are a wet sleeve, and you can see they're already finished. It's already got the nice crosshatch hone from John Deere. And basically, when you drop this in, it's different than some of the other sleeves you might have seen me do on my channel, where, you know, we have to, it's a press fit, so we have to press it into the block. In this case, there's actually O-rings at the bottom, and at the top it just sits on this flange, and none of it is press fit. So when I set my cutter up to cut the counterbore here, I want it to be big enough to basically just barely skim the outside of what's already there. I don't want to cut a bunch of material out, but I want to be big enough so that we are cutting the full bottom part of that counterbore. So as a rough measurement, because our bore gauge doesn't go, it's too short of a lip for our bore gauge to go into, I had to use the telescoping gauge. And I just kind of got an idea of the measurement, you know, using the telescoping gauge and the micrometer, and then I set my cutter to roughly that measurement, and kind of just by trial and error found the right dimension to where it was just skimming the outside of that counterbore. And the cutter I'm using here, obviously, like I said, I kind of got that dimension and set it using our setting fixture here, our setting micrometer, and basically, you know, got it set, and the cutter goes in and just cuts that counterbore for that flange on the sleeve to sit in. So now that I've got the first one cut, and I had zeroed the Z-axis on my DRO, I cut the second one. Sure enough, it checks out. Everything is good if I go to the same exact depth. So now I'm going to run through and do the last 4 cylinders. Got 3 of the counterbores done. As you can see, like especially on this one, you can see that there's still just a shadow of rust there, and that's how I know that I'm just barely skimming anything here. Like I said, I mean, I measured it and kind of did a trial and error with my cutter to get to the right size, but like I said, we don't want to make it huge, but we want to make sure that we clean up all the way around the bottom. So I've still got these 3 to go, and kind of as I go, I'm double checking my depth, and it's coming in at about 321 thousandths deep, which is exactly what I wanted. That's where, you know, this one came out and I test fit the sleeve and it was good. Same with this. So now I'm confident that I can cut the rest of these, and we'll double check along the way, but everything should work out. Last one. So that's brought down to the same zero as all the other last 5 of them. And there we have the upper counterbores done. Now we can move on to the lower bore repair sleeves. So now we're getting ready to do the lower bore repair rings. And one of the things we have to do is we have to bore to a depth of between 8,192 and 8,198 inches from the top of the deck to the bottom of where we want to bore to. So we're going to go right in the middle of that, 8,195. So what we've done is we've ran our cutter down to be at the 0 of the deck, and now on the Z-axis I'm going to set it 8.195. And now, when we run this down, when we get to 0, we know we're at the depth that we need to be for boring it out to fit our counterbore repair ring. We've also measured all of our counterbore rings using our micrometers so that we could get what size we need to bore the block to, because we have to cut out a section of the block. The block is already made with the, what do you call it, O-ring grooves at the bottom, but we're boring that out to put the repair sleeve in, since those are all corroded and kind of rusted away. And we want 1,000th press fit on those, so we've measured that and set our cutter so that we're going to have our 1,000th press. So we got our first lower repair ring in, and as you can see, I mean, it's going to look exactly like the original did with the O-rings cut in the block, except it's in a, you know, separate piece that is then press fit in with some Loctite sealer so it doesn't leak, and that way they'll have a good surface for the O-rings to seal, compared to some of these that are just completely chewed up and eaten away from the rust. So again, first thing I'm doing is getting centered on the original part of the bore. So I've got my centering finger in there, and we're centered up pretty well. And I've locked down the table so it won't move at this point. So part of the interesting thing that's kind of a pain on this is the cutter that, you know, to bore it to the size it needs for the repair sleeve at the bottom is actually too big to run down in like we normally would. Normally you would put the cutter in, run it down, and you'd be good to go. But on this, we have to run the spindle down and then put the cutter in through this hole in between the two cylinders. So this is nearly impossible to film, but I've got the spindle running, and we're gonna run it down to the 0 on our Z-axis that we already set from doing this cylinder. So I'm doing this all by hand just to be safe, because we could do this with the machine just engaging it, but it's a little risky. So there it just started cutting. A little bit below, but that's okay. Now, again, my normal habit would be to stop this and run it all the way up, but if we do that, we're going to break the cutting bit when it hits up here. So I'm going to run it back up to that same hole so that I can pull it out. And luckily it stopped in alignment with the hole, so I don't have to do anything complicated there. There's the cutter, and now we can run this up. So now you can see down in there, maybe if I get the flashlight back out, you can see where we've bored the bottom counterbore now so that we can press our sleeve into place. Here I'm just showing the before with the original O-ring grooves that are damaged compared with the counterbore cut to accept the repair rings. So we've set our bore gauge up to the size of the repair sleeve, or ring, or whatever you want to call it. And they're supposed to have around 1,000th press fit. And if you can see here, we're right on that range for where we've bored. You can see that we're going to have 1,000th interference between the ring and the parent bore of the block that we just bored. So everything should go in super well. So we prep the bore by blowing it out, making sure that it's clean, and then we're going to put some of this Loctite retaining sleeve retaining compound on it. The other thing that's kind of counterintuitive about this is obviously we have a nicely, round machined repair ring, but it doesn't fit through the top of the block. So you actually have to kind of force it through, and it'll compress enough to get through the block, and then you turn it into shape, into the right position and drive it on the rest of the way in. There it's through. So another thing we've done is we've taken an old sleeve for this engine and we've ground it down so that it can be used as a driver to drive these into place. So as you can see, they'll fit right over that, just like they do on when the actual sleeve is in service basically. And that way we can use this to drive it into place. May or may not need another hand. So now I've got it dropped into place with the repair sleeve or repair ring down in there so that we can drive it into place. If you watch my TikTok, you probably saw me doing something similar recently, and I smashed my hand, so I'm a little more careful now. But luckily, these, with only 1 thou of press, they go in pretty easy, especially with how small they are. I'm just going to wipe off any excess Loctite. And this is actually the brand new sleeve. They're finished. I think I might have already said this earlier in the video, but they're a finished sleeve. They just, a wet sleeve, so they just install, and they don't have to be bored or honed or anything like that once they're installed. And that seems like a pretty good fit. Here's a little time lapse showing the entire process of installing the repair rings on the final 3 cylinders. This is the kind of job where you spend a ton of time getting your tooling set up, verifying your fixturing, and getting the process thoroughly planned, but once you have all of that in place, the rest of the job is a breeze. With this being my first time performing this type of repair, I spent a lot of time asking my dad questions and double checking that everything was correct before moving forward. These type of jobs are never something that you should rush, and it was especially important for me to take my time so that I can learn for the next time. All right, so that kind of wraps up all of the repairs that we're doing on this block. We, like I said, we repaired the upper counterbores, we decked the block, and we also did lower bore repair rings. So at this point, all we have to do to finish up our work on this block is basically we'll run it through the jet wash again, and we'll put new cam bearings in it and tie up a couple other loose ends, and it'll go off to the customer and they'll do the final assembly and get this back rolling. So if you have any questions, be sure to drop them in the comments. I try to read most of them and I try to answer most of them. If I don't get back to you, send me a message on Instagram. I'll definitely see that one more than likely. And don't forget to like and subscribe for more content like this, and check out our TikTok channel and, like I said, our Instagram and our Facebook. And also don't forget to check our website and our eBay store. Thanks for watching.